YouTube. Moving on, let's do a cosmology segment, and this one should be somewhat feature-rich. Let's talk about cosmology, shall we? First of all, our mission. So we've started a science foundation, which is why we purchased the website smAsho.org, which will redirect you to the website smAsho.com. If you head to smAsho.com/forum/mission, you'll see our mission. And number one is to assist, study, and report on the ongoing formation of a unified theory of physics. Also to raise the awareness of the general public of the relationship between space weather and Earth effects. Your weather largely comes from space. To connect and consult with media organizations and multiply our reach, hence videos like this one. To demonstrate cutting-edge proof-of-concept solutions to problems. To publish scientific papers in a multidisciplinary manner, including but not limited to sciences like spectroscopy and the rest listed here. Astrophysics and cosmology also on the list. To assist mankind by advancing the study of predictive phenomenon, to do things like optimize value, reduce risk and liability, save lives and resources, and adapt, no matter what the adversity is, and to not be ossified in our beliefs, and to treat those who are with love, respect, and inclusion to the scientific discussion. Sometimes it takes a long time for folks to catch up with the new science. So that's part of what we're doing here. We're a news distillation service. We're also doing cosmology, astrophysics, geophysics, and so on, as I've been believing for a long time, since the mid-90s, that astrophysics and cosmology are in the process of being rewritten. Really, all the physical sciences are in the process of being rewritten. So help us out. Support us by clicking on our links. Visit smAshomash.com, smAshomash.org, become a patron, etc. Maybe check out our forum. We've just updated it yesterday with a forum post in the Sun forum about grand solar minimum. So we've just put up a couple of posts here with a chart and a link to an article about solar activity over the past 1,000 years from proxy data from carbon-14 to carbon-12 ratios in wood, which tells us cosmic ray flux, which likely tells us solar agenda. Not solar agenda. The sun doesn't have an agenda, does it? Anyway, perhaps check out the forum, and you can find links to all of that at smAshomash.com. Let's talk about the structure of the galaxy. Now, you may think that there would be jets coming out of the galactic core in this sort of a fashion, perpendicular to the galactic plane. But that's not the case at all, as Sagittarius A star's poles appear to not be aligned in that fashion at all. They're greatly offset. So rather than like this, Sagittarius A star must be on some kind of a acute angle, more like this. And so this article here, this is a phys.org article from which we took this image here. And this is showing you all kinds of things like the Large Magellanic Cloud. And there you can see Cygnus. And over here is the Vela Pulsar. But this article is about the North Polar Spur. So there is some argument about how far away the North Polar Spur is. And the North Polar Spur is, well, it's a giant jet of plasma emanating from sort of near the inner portion of the galaxy, but there's argument as to what it even is. It could be a supernoval remnant in the foreground. Perhaps check out this article if you like. It's on phys.org in the Astronomy and Space section. And it is one of the largest structures in the Milky Way. It can be seen in radio and X-ray wavelengths. So perhaps have a read on that. And if you want to learn more about the structure of the local area, head to plasmascape.com. So at plasmascape.com, you can find yourself with a link, plasmascape.com/plasmascape_007. If you click that link, you will find yourself on this screen. Let me give you a quick tour of what this is. You're looking at the solar system here. This purple ring, this is Pluto's orbit. Here's Neptune's orbit, Uranus's orbit. And if you press the A button will bring out all kinds of little tabs here. And what those tabs are different, obviously, directional vectors here. So this one's pointing at the North Galactic Pole. And right now you're on zoom level 1. You're not on zoom level 1. You're starting out on zoom level, I think it's zoom level 2 you start out. There you go. So there's zoom level 2. And you can move this all around. This is a three-dimensional visualization tool. And so what you were looking at is actually toward the galactic core there. And there you can see the North Galactic Pole. And that spur would be up in this area somewhere, up around here. But in any case, what this is showing you is some important information. So first of all, you see this right here, the solar apex. That is where the sun is moving in relation to the local chimney. So if you zoom out to level 5, you will see this hourglass-shaped feature. If you zoom way out, this hourglass-shaped feature, this is a feature of dust and gas in which the local stars are located. The local interstellar environment looks about like that. And allow me to get off screen while I continue here. And this entire structure is moving towards Cygnus. So Cygnus is this bright spot you can see right here on the galactic plane. That's Cygnus. And this entire structure is moving in that direction. Within this structure, and we know this by looking at the real motion of stars, which we can calculate mainly by parallax, because these are all fairly close stars. So again, this structure is moving roughly like that. However, the sun is moving like this in relation to other stars within this structure. So that's just a little bit of a tour there. Again, the solar apex, that's the direction the sun's moving within the local chimney, and the local chimney is moving toward Cygnus, toward the star Deneb, coincidentally. And that's right by this bright spot here under my pointer. And you can find all this at plasmascape.com. And these are the different zoom levels. So if you press 1, it'll zoom into the inner solar system. Here's Mars's orbit. Number 2 will bring you out to just outside Pluto's orbit. 3 will show you the heliosphere. So this will zoom it out. Now the heliosphere is probably not shaped like that, like a sphere, but it's just a visualization tool for astrography, meaning the location of where objects are. And here's sort of another in between the local chimney and the rest of the interstellar environment. And then at number 5, you can actually see the local chimney, sort of the local interstellar structure. So check that out, perhaps, plasmascape.com. Next, we're going to pick a random object here and check it out on the Neil Gorell Swift-Bat X-ray Observatory. This one is the second, close to the end of the list there. It's number 1002. So this object coincides with something. We've picked a quantum random number here between 1 and 1031. 1002. What might it be? Well, turns out that it's Quasar 4C. 4C-03.79, a quasar. And quasars are very important, folks. They are galaxies where you're looking directly down the poloidal field of the galaxy. So these tend to be very bright. And in the mid-90s, we didn't even know what these were or how they could be so bright. Now it's known that it all comes down to perspective. And we appreciate when our viewers have perspective and have some clue about the structure of things like galaxies and the Milky Way galaxy, for example, and also the interior workings of the sun, perhaps. So in any case, here is the transient X-ray map. These are the X-ray outputs. There's the historic graph going back about 16 years. Here's a 30-day graph. And it looks like it may have shut down here in X-ray. This is the 2-day chart up here in the upper left. And let's take a look at this with the SIMBAD visual tool. And you can see that bright orb there. Typically what quasars look like. No real surprise there. Quasars typically appear to be spheres. What's interesting about a quasar, folks, is if you weren't looking directly down the poloidal field of this thing, it may look like this, like a spiral galaxy. But because you're looking directly down the pole, you're getting this extremely bright imagery instead. There is a poloidal field associated with that region of all galaxies, it appears. And this all has to do with the magnetic orientation of the galactic core. So in any case, here it is on the 2MASS, which is infrared light. And let's take a look at it on Chandra. It should show up in X-ray, and there you can see it on the Chandra X-ray telescope. Great view of that quasar. Quasar 4c 3.79. And you can find all these things yourself at the Neil Gorell Swift-Bat X-ray Observatory. It's a transient monitor that monitors X-ray flux from these objects. And that's today's Cosmology segment. Let's move on to